Hello everybody, hopefully you're doing well, staying safe and taking care of yourself. We'll start up with our new lesson, chapter 12, lesson 4, heat. Please have your books with you and your pen or pencil to take notes and prepare your questions. So heat. Let us say you hold a mug of chocolate. Energy moves from the mug to your hand. It's a hot chocolate, right? Now since the mug is hotter than your hand gets warmer as it absorbs energy from the mug. Now if you put ice cubes into your drink, energy flows from the hot liquid into the cold ice. The drink cools as transferred energy melts the ice. So this is what actually heat is. Heat is the flow of energy from one substance to another. Heat is a form of kinetic energy caused by the movement of the molecules that make up all matter. Remember kinetic energy, which was the energy of motion. If you warm something, such as a cup of soup, you increase the movement of its molecules. The substance then becomes hotter. As an object is heated, the total amount of kinetic energy or thermal energy within the object increases. The total amount of thermal energy in a substance is measured using a calorimeter. The metric unit used to measure this energy is the calorie. Calorie is the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. Now, a thermometer placed in boiling water registers about 100 degrees Celsius, right? The thermometer measures the temperature of the water. Temperature is a measurement of the average kinetic energy of the molecules in a substance. So as you see lower average kinetic energy means less energy is there. As the heat flows into a substance, the kinetic energy of the molecules in the substance increases. Some molecules in a substance may move faster or slower than other molecules, but overall the average speed of the molecules rises. It gets up. This causes an increase in temperature. This increase in energy can also cause molecules to move further apart. As the molecules in a substance spread out, it usually increases in volume. As you can see here, an increase in volume that is caused by an increase in temperature is called thermal expansion. Scientists, engineers, and architects consider the effect of thermal expansion when choosing materials to build houses and other structures. Now, not all materials respond to change in temperature. In the same way, some may expand more than others. So thermal expansion again is an increase in volume that is caused by an increase in temperature. This is thermal expansion. Now we come to the 3 ways of how heat energy moves. Heat energy always flow from a higher temperature material to a lower temperature material. That is why in the for example, the water in the we put water inside the water, you put plastic bags, right? So the water in the plastic bags increases in temperature when it is placed in the beaker of warmer water. But as the warmer water cools, some of its thermal energy is transformed to its surrounding, which we could say just evaporated there. So we come to the first way of transferring the heat is conduction. Conduction is the heat energy that can move in the movement of energy through direct contact when there's a touch. This means that the two materials touch or energy flows directly from one material to another. Conduction is the only way that heat energy can travel through solids. Conduction are materials that absorb heat and distance it eventually throughout an object. Now, most materials are good conductors. Insulators are material that absorb some heat but do not transfer it very well. So if you place your hand on a piece of wood, the area under your hand would warm, but the temperature of the rest of the wood could not change. Now this is why we call it wood is a good insulator. So insulation is any material used to prevent heat from flowing in or out of the substance. This is what in insulation we use insulators which do not allow heat or or you could say sometime electricity to pass through it. The second way is convection. When you heat a pot of soup, some heat energy is transferred through the direct contact between the pot and the soup. However, most of the heat is transformed as the heated soup located near the bottom rises and moves around the part. So movement of heat within liquids or gases actually is called convection. Convection is the transfer of energy by the flow of liquid or a gas. Convection occurs in the liquid and gases but not in solids. Remember, convection does not include in solid. Convection occurs because most liquids and gases become less dense when heated. Their particles move faster and further apart. Convection cycles are responsible for the transferring energy throughout Earth's atmosphere and oceans. Now, radiation is the energy, movement of energy without any help. Energy from the sun reaches the earth by radiation. Radiation is the transfer of energy by electromagnetic waves. Radiation can travel through gases and the vacuum of space. Objects that absorb radiation gains energy. Now, the sun is not the only source of radiation. All objects give off a range of electromagnetic waves. Now, objects that are near or below room temperature gives off infrared radiation, which our eyes cannot see. However, when objects are heated to about 600 degrees Celsius, they give off a greater deal of visible light. We see this visible light is dull red, glowing like that of a stove top burner. When you burn a stove, you see it gets red, so that's radiation energy. It will be releasing that radiation energy. So conduction, which is the release of heat energy when things are touching, mostly in solid. Convection, the movement of heat energy within liquids or gases. And radiation is the movement of heat energy as electromagnetic waves, especially high energy particles. Then, as I told you, convection is what causes the amount of energy. It causes the transferring energy throughout Earth's atmosphere and oceans. That's through convection. Also, for example, let us say heat flowing. When we are cold, we try to trap heat energy around our body, and this is why winter clothes are often made of materials that are good insulators, because we said insulator does not allow heat to pass through it, or it saves. Now, it does not allow the cold air to pass and saves the heat inside. The heat that you have already it's protected inside. But in contrast, summer clothes, they're often light in color and made up of thin, lightweight materials. They absorb less energy and allow heat to flow away from the body easily. So that was our lesson for today. Hopefully it helps. Any question, just please feel free to ask it. Thank you.